In this video, we are going to continue talking about ionic bonds and learn about formula writing and naming ionic compounds. Alright, so the reason why something bonds is because it wants to form a compound and be more stable. Compounds have very different properties than an element alone. So the example that we've been using is sodium chloride. Sodium by itself is a shiny silvery metal that is extremely explosive. If you put it with water, it creates this huge explosion because it's so reactive. Chlorine by itself is this poisonous green gas. But when we put sodium and chlorine together, we make sodium chloride, which is a lot more stable. It's table salt. We can eat it. It can sit sort of out in the environment without reacting. So when we write a compound has a chemical formula. It tells you the elements and how many atoms of each element are in that compound. So water is H2O because it has 2 hydrogens and 1 oxygen. C12H22O11 has 12 carbons, 22 hydrogens, and 11 oxygens. Iron oxide has 2 irons and 3 oxygens, and sodium chloride has 1 sodium and 1 chlorine. So in a formula, the parts of the formula are the chemical symbols, the subscripts, and these tell you the number of atoms. Okay. So we need to know, in order to write a formula for an ionic compound, we need to know the elements that are bonding and the numbers of elements, the elements' oxidation numbers, which is their charge when they become an ion, and we need to know that compounds formed are neutral. Okay. Now, we're specifically talking about ionic compounds here. So if we look at this list, H2O, that is between a nonmetal and a nonmetal. So this really isn't even an ionic compound. NH4, that's 2 nonmetals as well. So this is a different kind of compound we'll talk about later. But lithium nitride, this is a metal and a nonmetal. So that is an ionic compound. And we'll talk about how we know the numbers here. So how we know there are 3 lithiums and 1 nitrogen. Okay, so we need to look at oxidation numbers. Oxidation numbers, again, like I said, is the charge of an ion when it gains or loses an electrons. And again, we can predict that from the periodic table. So metals, they tend to lose electrons, so they become positive. Calcium's in the second group, or the second column on the periodic table. It has 2 outer shell or valence electrons. Therefore, it's going to lose those electrons and become positive. Phosphorus is number 5, or is in column 5 on the periodic table. It wants to have 8, so it's going to gain 3 electrons, and so it becomes negative. Okay, and again, remember, it's really important that you have this written on your periodic table. If you don't, then do so now. And this will not be written on the periodic tables again you have on the test, but as you use it, as we learn to write formulas and names, it'll be important for you to help you memorize. Alright, and the last thing that we need to know is that compounds are neutral. Okay, so an ionic compound, each ion has a charge, but when it comes into a compound, they are neutral. So all the pluses and the minuses will balance out. All the positive ions, or cations, will balance all of the negative ions' charge. Alright, so let me just give you an example. This is calcium fluoride. It's CaF2. Now, calcium has a charge of +2, so with just 1, the total charge of all the positive is +2. Fluorine's oxidation number is -1, so we need 2 fluorines, or fluoride ions, 2 negative ones, to get a total charge of -2. +2 minus 2, net charge is 0. So the charge for the entire compound has to be 0. Okay? Now, in order to write formulas, we are going to start by learning to write formulas for binary ionic compounds. Okay, and we say binary, which means 2, because it's between a metal and a nonmetal. Okay, so we're going to learn a cheat for writing formulas. It's called the criss-cross method. So the example that I'm going to give you is beryllium phosphide. So the first thing that we're going to write, you always put the positive ion first. So beryllium is Be, it has a +2 charge. Phosphide is P, it has a -3 charge. And what we do is we crisscross the numbers down. We don't bring the charge, so we don't bring the plus or the minus, but we just bring the numbers. And we get a compound, and the correct formula is Be3P2. Okay? Now, remember, it's supposed to be electrically neutral. Okay? So if you have 3 plus 2s, that's a total of +6. If you have 2 minus 3, that's a -6, so +6, -6, for a net charge of 0. Okay, so that is the crisscross method, and then we call that beryllium phosphide. So the method is to write the symbol of the cation, okay, the metal first, with a charge, then write the symbol for the anion, the nonmetal, with a negative oxidation number. And then we bring the charges down without the sign. Now, the last step is to reduce the subscripts to the smallest whole number ratio. Now, and I'll give you an example of this, okay? We always want to have the smallest whole number ratio. So you might have to reduce the number. Sometimes, as in the example I just showed, we don't have to reduce the number. But let me give you an example. We'll see an example here in a minute where you have to reduce. But let's just practice, okay? So if you look on the periodic table, you can see that aluminum is a +3 and oxygen is a -2. So we would have Al2O3 for aluminum oxide. Lithium nitride, it's a +1. Nitrogen is a -3, so we would have Li3N. Crisscross down. Now, another thing to notice is that when you only have a 1, you don't have to put the 1. Just by putting the symbol, we assume that there's 1, so you will never have a subscript in a chemical formula that is the number 1. All right, let me give you one more example. The beryllium oxide is the example I'm going to give you, where we have to actually do that fourth step of reducing the numbers. So you have beryllium as a +2. Oxygen is a -2. So if you were going to crisscross down, you have 2 berylliums to 2 oxygens. Well, that's not the lowest whole number ratio, right? We're actually going to reduce down, and it's 1 beryllium for every 1 oxygen. So make sure you're always paying attention to the whether or not you need to reduce to the smallest whole number ratio. Okay? Now, naming, okay? When we see a formula, okay, we always start by writing the name of the positive ion first, okay, and then we write the root of the negative ion, and we change the ending to IDE, okay. So all the examples that we've already seen have been using this method. To give you sort of an example, and you'll start to know, usually the root is the first syllable. So here it would be ox, so it would be oxide. Phosphide, nitride, sulfide, okay? And you'll start to learn what those are as we use them and you hear them, okay? All right, so just an example, if we were to look here, you can see that you have lithium first and then nitrogen, so it's lithium nitride. Calcium and fluorine, so it's calcium fluoride. Aluminum and oxygen, aluminum oxide. Okay, so these are pretty simple to write the formulas for. Okay, so now after this, you should be able to do simple formulas and name simple ionic compounds. We will learn in the next video about certain cases. If you noticed in this video, we never used transition metal, and I'll talk about transition metals, and I will also talk about polyatomics.